Good morning, madam. Myself, M. Paul Reddy. I am studying in SRIT Engineering College, second CSM. My roll number is 234G1A33C0. Now I am going to explain about backward chaining and resolution. Let us see what is that. Now, introduction to backward chaining. Backward chaining is a reasoning method used in artificial intelligence and logical programming. It begins with the goal or hypothesis and works backward to find supporting facts. It means actually the backward chaining is starts from goals state and reach to the initial state or hypothesis or supporting facts. To find that supporting facts, it may works. This technique is particularly useful in expert systems and rule based applications. This is mainly used in expert systems or application systems. It can contrast to forward chaining, which begins with known facts and applied rules to derive new conclusions. Backward chaining operates from the desired outcomes and attempts to find the path to the initial facts. Backward chaining is a problem solving strategy used in artificial intelligence, expert systems, and logical programming. It involves works backward from the goal or hypothesis to find a supporting fact or evidences. It means basically this backward chaining system is mainly used in strategies and problem solving methods. Once we observe the diagram, here are the four facts and operators are and or operator is there and decisions, and finally they reach to the rule based systems. How backward chaining works: the process starts with the desired conclusion or goal. Actually the process is starts from the goal state. Each step involves checking if the goal can be satisfied by existing fact or rules. It may decided to whether it is enter to the facts or rule system that rules are satisfied at nor. If a goal cannot be satisfied, the method recursively seek to prove the sub goals. It starts with a hypothesis and works its way back to the supporting fact or premises. Backward chaining is recursive in nature. Actually the backward chaining is recursive. Here are the step by step explanation how the backward chaining is works. Now let us see. Step 1: define the goal. Actually we need to define the goal. Identify the hypothesis or goals to be proven. Represent the goal as a logical system. We need to find the goal states. Where we need to find that goal set. And step 2: retrieve relevant rules, search the knowledge base for rules related to the goals. Select rules that have the goal as a consequences. Apply rules. Now we need to apply the rules while we select the goal state. Apply each rule to deduce sub goals or intermediate conclusions. Use logical inferences to derive new facts. To find the new facts, we need to apply the rules. What are the rules we have? Now recursively apply rules. Repeat step 3 until facts or evidences are found. No more rules can be applied. A contradiction is dedicated. Now we need to apply the rules until we find the facts. Now step 5: verify the goal. If facts or evidences supports the goal, verify it. Otherwise, reject the goal. We need to verify it. If it is not verified, then reject the goals. Applications of backward chaining. Backward chaining is widely used in medical diagnosis systems to infer conditions. It is employed in natural language processing to derive meanings from sentences. That this technique is also useful in planning and decision making systems. It is particularly useful in sensors where the goal or outcome is clear. Basically this backward chaining system is used in medical diagnosis systems and also language processing devices and decision making system. This it is particularly useful in sensors where the goal or outcome is clear. Backward chaining can be used in adaptive learning systems to help students reach a learning goal. Natural language processing NLP perhaps parses sentences, identifies relationship. Planning and decision making finds optimal solutions. It may backward chaining may provide optimal solutions. In robotics, tasks planning execution, we can use in robotics also backward chaining system. Now let us discuss about introduction to resolutions. Now let us see what is resolutions and how it works. Resolution is a rule or rule of inferences that deduces a conclusion from two or more premises. Resolution is a fundamental rule of inferences used in logic, particularly in propositional logic or first order logic. Basically, this fundamental rule is resolution of fundamental rule is used in first order logic or propositional logics to derive conclusions from a set of premises or classes. Now, this resolution system is used to find two or when the classes are two or more, then we use this resolution system to find the conclusion to derive the conclusion. It is used to derive contradictions from a set of clauses in a logical expressions. This method is essential in automated theorem providing and logical programming. It combines two contradictions clauses to produce a new class. The resolution system is works by combining two or more clauses by producing a new classes. Now once we observe this diagram, here are the two different clauses which are combined to form finally one conclusion. The resolution process involves converting statements into a clauses form. Actually, this process is involves converting statements into clauses. It looks for pairs of clauses that contain complementary literally to resolve. The output is new class that is a logical consequences of a input clauses. This process is repeated until either a new empty class is derived or no new information can be produced. We need to continue this process until we get the new class while finding that class. While we observe this diagram, here are the two classes which are formed the new class, and another two classes are again formed the new class, and finally hence we reached to the goal state. This process is mainly used combination of two classes and finding the formation of one class. Now resolution rules. Let us see what is that rule. If P implies Q and P are true, then Q is also true. If one of that statement P implies Q statement, if P is true, then automatically Q also true in resolution systems. How resolution system works? Start with a set of premises P1, P2 and so on Pn. Here P1, P2, P3 and so on Pn are the premises. Apply these resolution rules to deduce new classes. We need to apply these rules to find the new class by combining of two classes. Repeated step 2 until a conclusion is reached. We need to repeat that system of combination of classes until we find the conclusion system. Types of resolution. Actually we have three types: unit resolution system, binary resolution system, hyper resolution. What is mean? The unit resolution is also known as use a single premises. It is used a single premise. It means it may forms the goal state by using only single premises. Binary resolution use two premises. We can find the goal state or conclusion state. Hyper resolution, we use multiple premises to find the goal state. Applications of resolution: theorem proving, automated reasoning system, artificial intelligence, expert systems, decision making, logical programming, database system, formal verification. These are the applications of resolution system. Advantages of resolution system: efficient, sound, complete. Efficient means reduces search space. We can reduce the search space by using resolution system. Sound, we can also ensure logical correctness by using resolution system. And complete, guarantees conclusions if valid. Now backward chaining versus resolution. Backward chaining is a goal directed resolution type. Resolution is proof by contradiction reasoning type. Backward chaining is a more efficient. Resolution may be less efficient. Backward chaining works with a rule based system. It may works by the rule based system. Resolution requires conjunctive normal form. It may requires the conjunctive normal form. Conclusion: both backward chaining and resolution are vital technique in AI and logic. Backward chaining and resolution are essential techniques in artificial intelligence. It may essential logical programming and computer science also it may essential. Both methods are foundational in the development of intelligence system, and their complementary strengths ensure that they continue to be essential tool in various applications of artificial intelligence, logic programming, and automated theorem proving. By mastering backward chaining in resolution, developers can create efficient intelligence and logical system. Both are essential in artificial intelligence system and logical systems to they are individually performing their performance in separately. Both have same uh, premises. Thank you for giving this opportunity.